All right, students, this is Unit 6, Polygons. We're going to be talking about coordinate proofs. Coordinate proofs, lesson 6.5. Taking a look here, don't forget a date, time, and location, as well as a parent or guardian sign off. Here's a quick review for you, one dealing with trapezoids, one dealing with a rhombus. Go ahead and do these two problems. Pause the video, do your own work, then restart. Welcome back. Let's see how you did. This first one we have here, this is a median equals, I'm going to color code this for you, base plus base over 2. Base plus base over 2. So you should have done circle plug chug, 5x minus 1 equals, and then we have here 21 plus 27 over 2. Since all of these are numbers, I'm just going to go ahead and you could do all the math all together. That's going to be 5x equals, that's 48 divided by 2, that's, 48 divided by 2 equals 24, that's 5x minus 1 on the left. So we do plus 1, 5x equals 25, and of course x equals 5. Once you define all lengths, so 5 times 5, that's going to be 24 right there. This one, rhombus, you should recognize this. Honestly, it's about the third time you've seen it. So hopefully you just know that the angles here are bisected. And the angles here, you add it up, take it away from 180. That's 12. That's 5. Have two sides, need third side. Pythag. You should have done 12 squared plus 5 squared equals unknown squared. That was 13. Walk it all the way around. That's about the third time you've seen that problem. Today we're going to talk about coordinate proofs. All a proof is an explanation. And when it's a coordinate, that means you're on an XY grid. So we're going to do an explanation on an XY grid, which means we're going back to slope, midpoint, and distance. So right here, I'd like you to just trace this line. If I wanted to find how that line tilts, I'm going to use the slope equation. So, and then there's two things that are related with tilt. Parallel lines have equal slopes. And perpendicular lines, the slopes multiply to -1. So keep in mind that when you're dealing with parallel lines, the slope is equal. Perpendicular lines, the slopes multiply to -1. So whenever your proof involves the tilt of a line, you're going to be using the slope equation. The midpoint equation will show if something is bisected. The midpoint equation will show if something is bisected or cut in half or has a common midpoint. So if I want to find the midpoint of this segment here, first I find my two coordinates, and we have an x and a y coordinate there, and an x and a y coordinate there. If I wanted to find the middle, it's add the x's, divide by 2, add the y's, divide by 2. So you use that when you want to find the midpoint. Distance equation shows comparative lengths. It can show that two lengths are equal in measure or congruent. So if I wanted to show that one length is equal to the other length, I would use the distance equation, where you subtract the x's squared, subtract the y's squared. So we're going to be going through how to prove something. We are given these coordinates. Right here, let's label our coordinates. A is at -1, 5. Always label your coordinates. So we're told it's a quadrilateral. We're going to be asked to show that it is a parallelogram. There's several ways to do that. First way is we're going to show this. If you have opposite sides which are parallel, then it's a parallelogram. So I want to prove that these two are parallel. So I want to prove that AB is parallel to DC. Then I want to prove that AD is parallel to BC. Parallel is a tilt issue. So we go back here. If we want tilt, we're going to be dealing with slope, which is y minus y over x minus x. So let's go ahead and set up our templates so we can do this quickly. Your slope templates look like this. That's a slope template. We're going to do AB here, DC, the two reds, then A to D, and B to C. We're going to do y minus y over x minus x. So let's do AB first. Y minus y over x minus x. So my y's, I'm going to go left to right, 5 and 3. And my x's is -1 and 3. Go ahead, do your own math. Watch out for double negatives. You end up with -1/2. Now let's come down here, D to C. Remember, it's y minus y, so you're going to go -2 and 4. -4. +2 and 6. Double negative makes a positive. We have +2 over -4. And again, you have -1/2. So we have just proven down here that those red sides are parallel because the slopes are equal. Equal slopes, parallel sides. Come over here. And now we're going to go A to D, y minus y. X minus x. That's going to be 7 over and that's going to be -1. Let's check the other one. Y minus y over x minus x. That was negative there, so this is going to be -3 right there. This is positive 7 over negative 3 again, so we just proved that those are also parallel. So you have math and then you have meaning. So here's our math, and then here's our meaning. Our meaning is the fact that they are parallel. Math has meaning. Same problem, except this time we're going to prove that opposite sides are congruent. So this time we're going to prove that AB is the same distance as DC, and AD is the same distance as BC. Get your coordinates on there. You're going to need them, so it's easy to work with. Let's set up our templates. Okay, so now we're going to go A to B, and we're going to go x minus x, parentheses squared. So I like to physically connect them. I have negative 1, positive 3. Then I have 5 and 3. Let me do the ones down below before I get closer here. This one's going to be 2 and 6. And 2 and negative 4. And you just do your math. This is negative 4 squared plus this is 2 squared. 16 plus 4. And I just found, don't drop your square root, that AB is root 20. Down here, do the math. And DC is also root 20. So we just proved mathematically, there's your math, and the meaning of your math is that AB is the same distance as DC. Or I could say the segments are congruent, which is exactly what we're ultimately going for. Right-hand side, I like to physically connect, so we're going to go touching the negative 1 going to 2. It's negative 1 and 2. Connect the 5 to the 2. BC, let's connect the 6 to the 3, or 3 to 6, excuse me, stay consistent. I'm going top to bottom. And this 2 right here is negative. That 2 right there is negative. Excuse me, that one's negative. This one's positive. All right, now we could do our math here. And this is negative 3 squared. That's going to be 7 squared. That's going to be root 58. Once again, mathematically, you have proven the fact that AD, distance to BC is the same, which means the segments are congruent. So we have proved that that is a parallelogram. Once again, you have math and you have the meaning of your math. Math and meaning. Last one that you should be familiar with is we're still going to prove it that it is a parallelogram. This time it's actually shorter. We're going to prove that the diagonals bisect each other. So draw on the diagonals. This is a pretty quick one. I'm going to do diagonal AC and then diagonal DB. Get your corners on there. Okay, all we have to prove that they bisect is the fact that we have a midpoint going both ways. So I'm going to find the midpoint of A to C, and then I'm going to find the midpoint of D to B. You add the x's, divide by 2. Add the y's, divide by 2. There's your templates. Let's do AC, our x's, circle them, circle the x's, box your y's. Let's do the other one while we're at it, circle the x's, box your y's. This one's going to be 5 over 2. And this, of course, is positive 1 over 2. On the right-hand side, that's 5 over 2, positive 1 over 2. You have proven that that is the midpoint mathematically going both ways. It's really easy if you graph this. 2 goes into 5, 2.5 times. So we can actually graph this, and you can see. I'm going to do this in yellow so it's easy to spot. So we're going to go over 2 and up 1/2. And this was graphed perfectly. You'd have a midpoint. So we've mathematically proven that the midpoints are the same going both ways. Therefore, it is bisected. So here's your math. And the fact that these two bisect each other is the meaning. Okay, we're going to do one more, and this is called a positive and a negative. A positive and a negative proof. It's 2 parts. Step 1, go ahead, let's graph these points very carefully and accurately. Okay, so this is called a positive and a negative proof. A positive and a negative proof. There's 2 parts to this. Positive and negative. So the positive. First, we're going to prove that this shape, TONE, is a rectangle. Is a rectangle. But is not a square. It is a rectangle, but not a square. It is a rectangle, but not a square. So there's a couple ways to do this. So you ask yourself a positive and negative. Let's stretch this out a bit. Ask yourself, what are the two unique qualities that make a rectangle a rectangle? Two unique qualities that make a rectangle a rectangle. The first one is that you have 4 right angles. Now, if I want to prove right angles, I have to prove lines are perpendicular. So if I want to go that way, I have to use slope. And then what else makes a rectangle unique is the fact that the diagonal lengths, if you draw them in, are congruent. The diagonal lengths are congruent. And if I want to show that, that's a distance concept. So I'm going to have to use one of these two to prove the positive. But I have to show it's not a square. So you ask yourself, what are the 2 ways that a square is different? 2 ways. Qualities of a square that are distinct from a rectangle, and the fact that all the sides are congruent. If I wanted to show that, that is a distance concept. Also, right here, how is a square different? Is the fact that the diagonals would be perpendicular because it's a rhombus as well. And to do that is slope. So you actually have a choice here. You do one of these two, one of these, to choose the positive, and then one of these to disprove the negative. For me, I'm going to do one of each. If I do 4 right angles, I have to do slope 4 times. But for the diagonal lengths, since there's only 2 of them, I only have to do that twice. So the first one, I'm going to show that the diagonal lengths are congruent. So that's going to be the distance E to U and T to N. So we're over here. We're going to do E to U and T to N. Okay, so we're going to set up our templates here. So the first thing we're going to prove is that these diagonal lengths are equal. So E to U, go ahead and make your template. And then T to N, make your template. Let's plug in our numbers. E to U, that's going to be, well, let's connect X to X. That's -6 to +4. Connect your Y's. That's 7 and +2. Down here, connect your X's. That's 0 and -2. Connect your Y's. That's 10 and -1. Let's go ahead and do your math here and see what you get. Taking a look down here, this one's going to be 2 squared, that's 4, plus, that's 11 squared, that's 121. Notice they are both root 125 in length. So we've just proven that it is a rectangle. Okay, now we have to disprove. So this gives us, yes, we have a rectangle. Okay, now we have to do the negative part, which is really easy. We're going to do the no part, which you find the same things. You're going to find the slope. Give me 5 minutes. 5 minutes. So we're going to find the slope of the exact same 2 here. Let's do the slope of EU right here. And then the slope of TN. Y minus y over x minus x, that's negative 7, 7 and 2, negative 7 and positive 4. Going this way, that's 10 and negative 1, 0 and negative 2. Go ahead, find your slopes here. We're just going to kind of bleed over a little bit. Top is 5, bottom's negative 10. That is going to be negative 1/2. This top here is going to be positive 11 over positive 2. You can see right away that these do not multiply to negative 1. So there is not a right angle there. So now we summarize. This is all math. Then you have to show the meaning of your math. Math and meaning. I'm going to type this so I don't inflict my handwriting on you here. So remember, there's a positive and a negative. So I'm going to just use a plus sign for the positive. The positive. Okay, it is a rectangle because the diagonal lengths were congruent. So you have to mention the math and then the meaning of the math. That's the positive. This is called a positive and a negative proof. Also, this is the negative. It cannot be a square because the slopes don't multiply to negative 1, so they are not perpendicular. In other words, the diagonals are not perpendicular. Therefore, not a square. You need to be comfortable with positive and negative proofs. That's going to be the majority of what we're going to be doing next class. Take a moment and review everything we've done so far. And the bottom line, just remember these 2 words, math, and then the meaning of the math. Math has meaning. New program, students just trying to figure out how to get this loaded up if you're wondering what's going on.